When is having an abundance of ear hair a good thing? Well, maybe when it kind of reverse deafness. And no, I'm not talking about the fuzzy kind of ear hair you can see on my ears. I'm talking about the sensory hair cells that grow on the inner cochlea, the ones responsible for detecting sound waves. Damage to these little hairs is common among people with some forms of hearing loss. And now researchers are developing a drug that can stimulate progenitor hair cells, giving them the ability to regrow and perhaps restore hearing permanently, perhaps even as an outpatient procedure. Given my percussion deafness, I'm happy to be the guinea pig for this one. With me is Jeffrey Karp, Associate Professor of Medicine at Brigham and Women's Hospital in Boston, Massachusetts. Welcome back to Science Friday.
Thank you. It's great to be here.
Why don't we already have a drug treatment for deafness? It's such a common problem.
Well, I think that, one of the challenges has really been that the biology has been lagging. And, one of the reasons for this is that, it's really simply we haven't had enough of these cells, the hair cells in the inner ear to conduct a lot of experiments. And I think this lack of, abundance of these cells, even in the laboratory, has really minimized the type of experiments we can perform.
And that's one of the things you've been able to do is get enough of these cells growing in the laboratory so that you can make experiments to try to regrow the hair cells?
Exactly. We knew going into this that birds and amphibians like frogs and toads and salamanders, they have the capacity to regenerate these hair cells throughout life. And when humans are born, they lose that regenerative capacity. You're only born with 15,000 hair cells per ear.
Wow.
And throughout life, those cells die and they never regenerate.
And so you actually found, by going into the lining of the intestine, the stuff that could regenerate the cells. Why the intestine?
Well, when we started this work maybe 7 or 8 years ago, we were really interested in developing a druggable approach for tissue regeneration. And, we were kind of envious of creatures like sharks that can regrow their teeth throughout life. We were envious of salamanders where you can cut off an entire limb and it regrows, or a tail. And we said, why have humans been left out of this regenerative process? And when we take a close look, we actually haven't been left out of this completely. The lining of our intestines can actually regenerate, and it does, every 4 to 5 days. So it's really the most regenerative tissue in our entire body. So it was really a great place for us to start our work.
This is Science Friday from PRI, Public Radio International. So tell us about what success you've had in using these intestine cells so far in the laboratory.
So we started with there's a stem cell in the lining of the intestine. And that stem cell is really responsible for this incredible regenerative process of every 4 to 5 days regenerating the entire epithelium. And so through trying to really understand the cues of how that cell is regulated, we were able to come up with small molecules, which, really standard types of drugs are small molecules that could regulate that stem cell and grow it in almost unlimited quantities in pure form.
So is it as simple as injecting the stem cells into the cochlea where the hair cells live?
So, cell-based therapy is definitely something that we're interested in. When we started this work, our idea was just because there's so much complexity around cell-based therapy in terms of expanding the cells and quality control, our idea was if we can target the cells in the body, the stem cells and the progenitor cells with small molecules, just standard types of medicine, we might be able to have a very powerful approach that could be quickly translated to patients. So the idea here would be to deliver these molecules to the middle ear, and they'd be able to diffuse across a membrane called the round window membrane into the cochlea, which is where these progenitor cells are located.
So you put the drug in, the progenitor cells make the hair cells. So how close are we for, going to the doctor's office and getting this medicine possibly injected into your cochlea?
So we were able to show in the laboratory that we could take these small molecules, we could isolate these progenitor cells from the inner ear, and we could expand those progenitor cells on the order of 2,000-fold beyond what anyone had shown before, and then generate huge populations of these hair cells. And so this work that we recently published was really, a big first step in this effort. We were able to obtain, very large populations of hair cells. We demonstrated that they had functionality, really bona fide hair cells. And we demonstrated this for tissue from mice, non-human primates, and even human tissue. And we formed a company called Frequency Therapeutics, which is in the process of moving this to the clinic, and they hope to begin human clinical testing within about 18 months or so.
That's like tomorrow in the medical world, isn't it? 18 months. You mean the ability to, as an outpatient, to go in, get an injection, and have your hearing come back? That's the idea.
Yes. Exactly. And, a lot of people have middle ear infections, and it's a very standard procedure for people to get antibiotics injected into the middle ear. It can be done as an outpatient procedure, in-office procedure. And so we envision really just kind of piggybacking on that type of infrastructure that's already available. And so really the goal here is to get the molecules into the inner ear, so we would just inject them into the middle ear and allow them to diffuse across. And it should be a relatively quick procedure.
Because there's so many people with stem cells. I have stem cell, I had a percussion deafness from a loud bang, and it's my hair cells, and all other kinds of people with hair cells. This would be really anticipated.
Yeah, there's so many ways that these hair cells can be damaged from loud noises, and it really doesn't take a long exposure. Age, even common antibiotics like gentamicin, chemotherapeutics, and it's even believed, if you take aspirin at 10 pills or 12 pills a day, that can also damage these hair cells. And because they never regenerate, people are really stuck with this, and there's no therapeutics right now.
All right, Dr. Karp, we're going to meet back here in 18 months, okay? And we'll see how this
sounds great.
This is going. It's fascinating. Jeffrey Karp, Associate Professor of Medicine at Brigham and Women's Hospital.